Hello everyone, everyone, our esteemed Susan Kumar Padhan sir, HOD of Community Punjab College Borgor, respected sir and madam, and my dear friends. So I am Abhishek Padhan, Department of Physics, Siram College Rampur. Today I will discuss a topic which is a cornerstone topic of physics known as quantum entanglement. Basically, it was taught by Einstein as the spooky action at a distance. Spooky action, the name was sound very uncomfortable because it was a topic which Einstein also confused until it was proven by other scientists like Planck and Asbach. So in this discussion, I will discuss about the quantum entanglement and its history and how it is used in our day-to-day life, like its application and some of its challenges and limitations. So before I start, we all know classical physics like the Newton first law, second law, third law, and etc. But the classical physics fails to explain the behavior of light and some atomic level. It fails to explain. So the quantum physics is needed in the science. Basically in 90s, a famous scientist known as Max Planck first gave theory of black body radiation. According to his theory, he said that the energy is basically discontinuous, like it's always found in packets that we call is quanta of energy. And later in 1905, Einstein explained the photoelectric effect, in which we get to know that the light behaves both the wave and particle nature. So it all conclude to the quantum physics, and later it was led by the famous scientists Heisenberg and Schrödinger by some statistical formula and mathematical phenomena. So this is the differentiation between the quantum physics and classical physics. In classical physics, it basically is predictable and deterministic outcomes, but in quantum physics, it is probabilistic and statistical outcomes. So now come to the point that is quantum entanglement. It is nothing but it's a phenomenon of physics where two particles entangle once and then they lose their individual identities and form a separate quantum system. And after some time, if we separate them at some distance, then if we change one particle, then it automatically gives the result of the another particle which was situated at a infinite distance to this. So as I say, Einstein is basically ମାନେ ଗୋଟେ ଏନ୍ତା ଟପିକ୍ ଯେନ୍ଟା କି ଇମ୍ପସିବଲ୍ ଟାଇପ୍ର ହେଲା ତାର ମାନେ ଗୋଟେ ଜିନିଷଟେ ଯେନ୍ଟା କି ଲାଇଟ୍ ଠାରୁ ସ୍ପିଡ୍ ଟ୍ରାଭେଲ୍ କରିପାରବା କେ ନା କରିପାରେ ବଟ୍ ଆଇନଷ୍ଟାଇନ୍ ଏଥିଲାଗି ଏଇଟାକେ ଟୋଟାଲି ଡିସଏଗ୍ରି କରୁଥିଲେ ସେ ସଦାବେଳେ ଇନକମ୍ପ୍ଲିଟ୍ କରୁଥିଲେ ତ ସେ ତାଙ୍କର କଲେଜ ଟାଇମ୍ରେ ଥିଲା ମାନେ 1935ରେ ଗୋଟେ ଇପିଆର୍ ପାରାଡକ୍ସ ବୋଲି ପେପର୍ଟେ ଲଞ୍ଚ କରିଥିଲେ ଯେନ୍ଟାକି ତାଙ୍କର ତିନିଟା ସାଙ୍ଗ ମିଶିକି କରୁଥିଲେ ଆଇନଷ୍ଟାଇନ୍ ପୋଡସ୍କି ଆର୍ ରୋଜେନ୍ तो तापर भितर आर्गुमेंट सदाबले चलीथिला that how anything can travel faster than light because here we get the information instantaneously without any delay of time. So Bell's argued with Einstein and he challenged him to prove that quantum physics is not basically incomplete. It is complete, but there are nothing variable which can travel faster than light. It's a phenomenon where he do an experiment with alien experiment. Later, they got Nobel Prize on it because they took entangled proton basically. They took to undergo photos and proved the thing that it is not due to the variable. It is basically a phenomenon. Like I am the example tenma quantum entanglement ଗୋଟେ ଦୁଇଟା ବକ୍ସ ଆନମା ତାପରେ ଚାहे ସୁ ରଖମା ଦୁଇଟା ବୋର୍ଡ ରଖମା ଦୁଇଟା ବକ୍ସ ରେ ଗୋଟେ ଫାଲେ ରାଇଟ ରଖମା ଗୋଟେ ଫାଲେ ଲେଫ୍ଟ ସୁ ରଖମା আর সেটাকে আমি ଗୋଟେ ইনফিনিট ডিসটেন্স রখমা ଗୋଟେ কে ইন রখমা আর ଗୋଟେ কে আমেরিকা ছড়িয়া তো লোক ଗୋଟେ আবার যদি ইন ওপেন করবা সিম্পলি সে কানা দেখবা যদি এটা রাইট আছে তার মাইন্ড রে অটোমেটিকলি আসবা কি আর এটা লেফট সুট তো ইনো ইনফরমেশন কিছু ভেরিয়েবল থেকে ট্রাভেল না হবা এটা খালি থিওরিটিক্যালি है तो सेटा जेतेबेले आइंस्टाइन के प्रूफ कराला तार पर एक बहुत एप्लीकेशन क्रिएट लाइक क्वांटम कंप्यूटिंग that is their major application because in our general computer you use binary number like 0 1 we use only single number but in quantum computing for mathematical calculation we use qubits that basically we use qubits in 0 1 together so it's for complex problem and another example is quantum cryptography here you can get a secure communication system like in our WhatsApp is in the end-to-end encryption बोलिए and our secure communication like যদি कैसी country ভিতরে inter country हो कि continental हो किसी যদি information transfer करा हो या में quantum secure network जैसे गोटे newly discover ये quantum की distribution सेटा यूज करी हम कर पारमा तो इधर क्या है implementation है चाइना उड़ जा सैटेलाइट लॉन्च हुई थी मिशन सैटेलाइट हुई से जो 7600 किलोमीटर तक रेंज तो ले बेजिंग सिटी रन लगे वियतनाम सिटी तो से वीडियो पर कनेक्ट करी एंड आउ बेटर यूजर सीजे लाइक यूरोपियन यूनियन और यूएसए रे गुटे लैब है हमर एनआईटी रो से भी क्वांटम क्रिप्टोग्राफी रो एडवांस टेक्नोलॉजी यूज करके होबे फ्यूचर प्रॉब्लम माने सॉल्व हो करबा हमने ट्राई करी So these are basically the advantage like we can get a security base on physical law and opportunity to a private global network but there are also disadvantage because it is too costly and there are technical complexity because it is too complex. So,